Wonderful. Well, at this point, I'd like to say a big thank you to the organizers team for making the first Kubernetes Community Days here in Munich so fantastic. And fingers crossed that we meet again next year. And now I head over to my presentation. I'm going to talk about Kubernetes for development, a bit of a journey of our company, how we migrated from Vagrant to Kubernetes and how we crashed our way up. So now I have to double click here. So I like to kick off my presentation with a short TLDR. So these are really the key takeaways from my presentation. Number one, I'm going to pitch you that developers should work with Kubernetes, ideally right from the beginning. Number two, Kubernetes for developers is still broken. And I think there is a tendency in the space of cloud native, and especially Kubernetes, there's a lot of focus in the operation sides of things, but developers are important too. Don't forget them. Number three, my team at Blueshoe, we are creating open source software tools for making this possible. We are potentially not there yet, and this talk is highly opinionated. So if you have another opinion, I'm open to chat. You can find me at the booth or working around, so get in touch, and then we can have a little debate. Well, I'm Michael. I'm a software engineer and co-founder at Blueshoe. I build a lot of software to run on top of Kubernetes. I had many mistakes, a few successes too, and I really love sharing my experience. So this is my team at Blueshoe. We're creating software that runs on top of Kubernetes, and we're also taking care about tools and softwares and workflows to make this as convenient as possible. So, chapter one, the why. Why should developers work with Kubernetes? Well, we've been told, especially developers, been told to shift all the things left, right? And it makes kind of sense to think about all the good things, like all the utilities early, like scalability, extensibility, reliability, and security. And I mean, this model emphasizes to pay more attention. If you look at software development as a process, even if you have an iterative model in creating those software, you still have a phase in which you more or less plan and architect the application, then it's in a build, and all the way down to monitoring, analyzing, tracing your applications on Kubernetes. And the idea is to make developers aware of the target platform, right? I mean, if we're looking back at like 2000 in the dinosaurs age, when Windows developer created software that runs on top of Windows, it was probably not required for them to understand all the details of the hardware abstraction layer, but it was potentially a good idea to at least understand a little bit of the Win32 API. And the same is for, at least in my opinion, when it comes to developing for Kubernetes, to teach our developers to understand the capabilities of Kubernetes and to making them aware of it. So, and then this model is probably older than Kubernetes. I think that this model also caused the term DevOps, which I'm not a big fan of, to be honest. I mean, we have the developers and we have the ops guys, and then there are those DevOps guys, which are, well, almost as hard to find as a panda bear. So then there's another thing that we have been talking about yesterday already. It's the 12 Factors app. So this is some kind of credo for software developers writing web applications. And it has been published by the engineering staff of Heroku. It's been inspired by Martin Fowler's work on architecting enterprise applications and refactoring. And well, if we want to honor the 12 Factors app for our software development process, we probably have to adapt Kubernetes for our development process as well. One example is the factor 3, which says store config in the environment. And I recently talked to a Java developer. I'm not a Java developer myself. And he said, well, we are shipping our Java containers with property files. And he told me, it is easy for us because we don't have the environment to be stored in Kubernetes, as our image already contains the configuration values for development, staging, and production. And I said, well, this does not really honor the 12 factors app, and it's probably not a good idea. But more important for us is the factor number 10, which states keep development, staging, and production as similar as possible. And we can only achieve that if our developers are working with Kubernetes, right from the beginning. So our reality in 2017 was that we had a lot of pet server in production. So those are the servers, if one of them goes down, it's like hell. And to meet our production environment, we created Vagrant files. We've been using the Ansible provisioner with it because in production we had things like AWX, VMs, rolling out everything with Ansible. There was a time when we also used Salt, but really quickly then changed to Ansible. And for our development environments, there were plenty of scripts for automation, right? Bash script, later on we mixed in some Terraform, and this was quite complicated. In 2017, we almost adopted container technology. At the same time, we decided to go for Kubernetes for all of our production workloads. And at that time, well, nobody in my team had a clue about Kubernetes or any certification or anything like that. So this brings us to chapter 2, the how. How can we actually achieve a development workflow that complies with Kubernetes? I have been lucky enough to talk to about 50 engineers of those companies, and we interviewed them with a sort of a standardized questionnaire, talking to them, okay, how do you run your workloads in production, and more importantly for this presentation, how do you organize your development workflows? And well, this led to those 3 types of denial that we identified. So even in the larger organizations, we found number 1 quite often, the outright denial. Those companies do not even adopt container technology during the development time. That means they're running Java processes, bare metal on their machine, and the code hits a container image for the first time in some sort of continuous integration, continuous delivery pipeline. And of course, they do have a lot of scripts, like custom scripts, make files, anything like that, to spin up their development environments. Then is the number 2. Those are teams having at least Docker Compose for their development. And if it is a larger organization, you have probably more teams. All of them are working with their own Docker Compose files for creating their services. And I mean, those developers get at least some fundamentals of container technology, technologies, writing images, executing them, all the ins and outs. And what we saw in those teams are that there is at least 1 or 2 members that have some sort of affinity towards Kubernetes. Most of the time, those are the backend developers. And they are then providing the Kubernetes configs for the applications, being like on the interception between the application development and running those services on top of Kubernetes. And then there is the 3rd type that I call ComSci ComSa. Those are organizations that provide like multiple ways, official ways, for developers to write services. That means there is a Minikube setup with maybe another tool that supports the workflow like Scaffold or Tilt.dev. Or they do provide a namespace namespace shared Kubernetes cluster for their developers. So those developers have at least the chance to look into Kubernetes, see what is going on, teach themselves a bit about Kubernetes APIs and the tools around in this ecosystem. And yeah, so in, I think, 2018, we directly fell for the second type, the Docker Compose type. So we decided, okay, Kubernetes might be a bit overwhelming for our developers, so it's better to start off with Docker Compose setups. And we had multiple teams writing services, and they eventually got together in a platform that was based on Kubernetes. And well, have we been happy with that? Not really, to be honest. And here I brought you our top 3 of the fails that we had back in these days. So number 1 is really one of my favorites. One developer decided to mount a volume in a Docker Compose setup and used native file operations. Like in Python, it's this open a method which you can call to create file, read files, modify files. And then eventually that service migrated into Kubernetes, where we decided to go with an S3 backend. And we had a hard time to find out what was going on here, because the service was creating files which didn't end up in our S3 bucket. And having a look into the code then finally showed us, okay, this is potentially a mistake that could have been prevented if our developers had the chance to work even locally with an S3 backend. Then there was another thing, a circular request dependency, service A called service B, called service A, and until all workers are depleted. And we found that one also on our staging system, and it was caused by 2 teams having 2 Docker Compose setups. We had a clear contract testing, so this was working fine. However, if there is a situation in which service A called service B, and service B can only respond with information from service A, then of course you have a circular dependency, and this is not going to work. Number 3 is another mistake that was actually happen quite too often. Developers define their own infrastructure, right? You give them the power, okay, you take the Docker Compose setup on your responsibility, and they decide, okay, I will go with a Postgres in version 14. And why not use the latest features of Postgres in version 14? Then service migrates to Kubernetes on the production infrastructure, and there is only a Postgres in version 13. And those latest features are not available anymore. You can think of the discussions we had then later on, removing the code that was depending on that new feature, finding workarounds to make it possible to work with Postgres 13, and I mean there are plenty of examples of that type of fail in our software development process. So we wanted to adopt a Kubernetes native development approach. This was around in 2019. So as I said, we wanted to use Kubernetes right from the beginning. Our developers should be aware of Kubernetes, get rid of Docker Compose and any other technology that might prevent developers coming in touch with Kubernetes. And the good thing that we found at this point was, if there's someone in the team, right, writing Kubernetes configs, like with Helm charts or with Customize or even plain YAML files, why don't we take those resources and bring it back to our developers? So this is like super efficient, because we have development environments that are really on par with the production environments, or very close to it at least. And we could eliminate at least 2 of the 3 software fails. But developers had to learn all the things Kubernetes, at least some basic knowledge about kube control, the resources, and everything, you name it. We wanted to foster service-oriented architectures, which was then finally possible because we had a clear approach for having service orchestration even during the development phase. And we also wanted to leverage Kubernetes to its fullest extent, right? This is especially important for all the Kubernetes patterns, like behavioral patterns, structural patterns, like sidecars for authentication purposes, for database connections, you name it, and of course the configuration patterns. And yeah, we looked into the market to find tools to support that. We've been experimenting with something like Tilt, but we found always, this is not really an efficient development process. We had building times for our containers. This was annoying for our developers. So we came up with this wonderful workflow. There is, as I said, some Kubernetes specialist in the team, someone who knows Kubernetes. And this is the one in the team creating all the dependencies, like databases, caching layer, full text search index, you name it, and put that into a Git repository for our GitOps workflows. This is then eventually the same source for provisioning our production environments. And then we have our software developers over here. I mean, they are communicating with our Kubernetes specialist, talking about environment variables, talking about the structural patterns that are in our workloads. Then they have just to install a Kubernetes cluster. They can select like Minikube or K3D or Kind or even MicroK8s, then generate the manifests, install them, and then use in addition some special tooling to make development actually happen. So have we been happy with that? Well, not really. Turned out not to be a good idea to have such a complex workflow for development. As I said, especially time-consuming and repetitive container builds have been a huge problem in our development workflows. Then this back and forth with staging environments, bringing in, oh, there was some mistake in writing the environment variable names, going back to the developer, fixing it, pushing it again. This takes time. Then, of course, too many and too complex tools was just overwhelming for developers that are usually live in their IDE, right? They don't want to, I mean, even writing good Docker files is still a thing for developers that are just want to write code. And then we came up with, hey, you need to use K3D or Minikube, which are tools that have their own complexity. Please use Helm to provision your development environment, and don't forget those 15 flags, customize, kube control, you name it. So way too many and too complex tools for developers. And then we even found that we have some unclear responsibilities talking about environment variables, or who in the end takes care of the dependency drift for our Helm charts, right? It's just they are laying around and getting old. If you are depending on Bitnami charts, for instance, you will find that they have a deprecation policy, and from time to time, the charts that you may depend on still are not available anymore. And this is hell. Then finding proper counterparts for the proprietary solutions of the managed cloud service offerings. I mean, for databases, this is usually quite simple, but if you depend on PubSub in the Google Cloud or S3 on AWS, it gets a bit tricky to find a solution for the developers to have at least a close setup. But you can find solutions for that. Especially for the S3 thing, we found solutions to provide our developers with an S3 environment on localhost, later on also in the cloud. And we could get rid of all the issues around having such a storage backend. So no Kubernetes conference without new tools, right? of course, we started our own tooling because we haven't been satisfied with the tools that were available at that time, and I couldn't spare you from bringing up this meme. It's like always, if you're looking at the Kubernetes at the CNCF landscape, it's getting harder to find out what's actually going on, and it's also interesting that we have talks that are just about describing what's the difference between like inner groups of the landscape. So yeah, we came up with one tool. It's called GetDeck, and for developers, it's really like a deck get on a repository keeping all the Kubernetes configs. And this tool creates a Kubernetes cluster of a configurable type. We're currently supporting K3D and Kind and hopefully Minikube in the future with the configuration. I mean, if you spin up a K3D cluster, you probably want to disable traffic as the default ingress controller because you're using maybe Nginx ingress controller in production. So it's the next point to coming closer to production, right? Then this command pulls all the Kubernetes sources that is made in one repository or distributed across multiple repositories, depending on the style that you're living in your organization. If you want, like, have your services and the Kubernetes configs to run them right beside of the code, then you have potentially multiple locations from where you want to draw the charts or the Kubernetes configs. And then, of course, generate the manifest in case it's customized or Helm, and rolling everything out with just one command. Plus, it manages the life cycle of a local dev cluster, so it's just as easy to get rid of it again, bring up another one. So this is very convenient for the development process. And the basic idea why we called it GetDeck is the concept of a deck that which allows you to, if you have like a huge project platform with like hundreds of services and attached resources, it's still probably a good idea to just create chunks out of it for your development teams, to have like, for example, a deck A, which runs two databases, a service on top of it, which is quite sufficient for a backend developer, or a deck B, you can't see it actually, which could be sufficient for a front-end developer having 2 or 3 backend services in a service mesh with databases and other attached resources and ingress configuration, and then creating a front end on top of the API. This is the deck file that we need to create working with GetDeck. So there's a cluster section which allows us to define the Kubernetes cluster for our developers. There are the port forwardings configured, the Kubernetes API is in there, and basically a name. And you can like tell if you want at least version 4.00 of K3D to be installed on the system, then GetDeck checks that too, so that we don't get any incompatibilities between different versions of those tools. And then there's a second section called decks. You can define a number of decks here, which then compiles from multiple sources. Like in this example, you will find the Kubernetes dashboard, which is, by the way, a good idea to provide to developers, because I think it's a bit underestimated how easy it is to click through a cluster, find the namespaces, jobs, pods, the logs, exec into pods. Everything's possible with the Kubernetes dashboard. And in this example, I have also a file, a type file that applies just a plain YAML file that's present in the deck file here. Then there's another tool. We had a talk yesterday about Gfira. In a nutshell, you can connect to any Kubernetes cluster, whether it is running locally or somewhere else. And you can just run a Gfira run, which is quite equivalent to a Docker run, with the neat feature that the container that you will be running will behave as it would be part of a Kubernetes namespace. So it is able to connect to all the resources running within the Kubernetes namespace and potentially in other namespaces too, if you configure it that way. And yeah, then there's another a fancy option that you're being able to overlay an existing container that is running within a pod in a cluster. And since this container is then running on your local host, you're free to modify it to your needs. You can override environment variables as a developer. Of course, you plug in your current working directory, and you can even connect a debugger to it. And we do have some other productivity hacks for working with Gfira. Just to name one, you can start with the Gfira run command, your container tailing -f def null, which just keeps the container alive. And then you can exec into it and start your Java process or your Go process. And once it fails, you can just simply change the code, start the process again, and you spare your developers from the time bringing up a container and do the connection stuff and everything. So this is one productivity hack. Another one is if you're working with VS Code, for instance, you can make use of dev containers, which is a fancy feature from the makers of VS Code, which allows you to take any container image and make a full-blown VS Code image out of it, which will effectively bring a development environment, an IDE, VS Code, into the cluster with all its features. And this really helps with a lot of other concerns. So, my last chapter, what's next? Well, as I said, we are not really there yet. We still have a way to go, especially since we want our tools to make them available to the 99% developers. So 99% developers are the developers shipping the real value, right? They want to write code, ship value, and go home. So those are not the hipsters like you and me going to conferences and always finding out about the new stuff. And for them, we have to add at least some graphical user interfaces, clicky bunty interfaces that will allow to use, in this example, Gfira without the CLI. So the heavy lifting is done. Now we want to integrate the capabilities of Gfira into VS Code, and in this example, a Docker desktop extension. And for GetDeck, on our roadmap is a extension called GetDeck Beiboot. It's a German word for lifeboat. If you have a Kubernetes cluster, in this case the host cluster, and it's like a ship, we want to spin up logical or virtual clusters, so to say, running on top of it for our developers, which are then dedicated. If you have tried to do this with Terraform on AWS, you probably find out that it will take about 30 minutes to bring up a new Kubernetes cluster. With GetDeck Beiboot, it's a matter of 20 seconds to have a new cluster running with the desired Kubernetes API. And GetDeck will then take care of pre-provisioning this cluster with all the resources specified in the deck file. And maybe another good idea would be to have like provision ephemeral like spot staging systems. That way, having one feature in it for a certain amount of time for the right people to decide if this is meeting the requirements. And also on our roadmap is the management of the life cycle of those clusters, right? If a developer has been disconnected for, like, let's say 24 hours or 48 hours, then you might want to get rid of it, which is also a matter of seconds. Or if you want to hibernate clusters by the end of the week and bring them up again on Monday. Well, that's it. Thank you very much for your attention. If you have any questions, feel free. As I said, I'm open to debate about all of this. Find me at the booth or working around. Yeah. And in any case, have a wonderful day. What?
Thanks for the talk. And just a quick question on Bybode. Is that essentially the same thing as vCluster or Capsule is doing?
Yes, but there are some differences in the technical implementation, to be honest. So vCluster, for instance, they provide a logical Kubernetes API on top of a host cluster, but they are syncing back all the workload objects into the host cluster. And Bybode provides a bit of a stronger isolation here. So all nodes are then visible as pods from the host cluster perspective. And the workload running within it is not visible for the host cluster.
Okay, thanks.
But it's quite similar anyway.
Hello, thank you for the talk. I have a question about the Docker desktop. I have lots of customers, they say, oh, Docker desktop, we don't want to use it because of subscription. And so does your workflow work with Ranger desktop, the open source solution?
Does Ranger desktop provide an extension capabilities?
No.
Then you're probably forced to either use the CLI or wait for a standalone UI of Defira.
Thank you.
All right. Thank you very much.